Yeah. Just give me your opinion first. How was it?
Actually, I tried the 1 to 3
Yeah.
question. But it is not. It is not trying to do that.
Okay. What about the simple harmonic motion? Yes, it's okay, you sure? And what else? Hooke's law, wasn't it?
Yes, also.
That was Hooke's law.
Also do the 1 to 3.
You could do it?
Yes.
Okay. Do you think we can skip the tutorial on Friday so we can continue? You think that's okay? Alright, so we'll start the next part then. Yeah.
In the Friday, I enjoy the going to.
Oh, yes, that's right. What about you?
I think I'm good.
Okay, so I might have another one on Friday. Okay. Hey, why are you late? Sorry, what? I missed your reason. Why are you late?
Reason?
Yeah, reason. You know reason? Excuse. Yeah.
I move slowly.
All right, yeah. Are you sick too? No.
Google's going to be there for some time.
Okay. Now, like I said, we finished part 1 of 6, the mechanics. So now we're on to part 2. This is part 2, the electricity. Now, the good thing is, you all do chemistry, so you all know what this is.
Yes.
Electron, yeah? What's the other one that goes with electron that's its opposite? So these electrons and protons, you both know they have a charge. Now with Lorraine, what unit do you use to measure charge? I think you just write, yeah, like you say electron is a -1 and proton is +1. That's okay for chemistry, but for us we need, we use a different unit. So we measure charge in coulombs. And the unit is C. Now if you have your calculator, so for an electron, we say it has -1.6 times 10 to the -19 coulombs, and a proton has +1.6 times 10 to the -19 coulombs. Now, can you tell me anything that you know about charges, how they behave? What things do you know about electrons and protons and charges?
The opposite charge repel each
Opposite charge, try again?
other. So that
Attract each other, yeah. So, if you have positive and positive, they push away from each other, don't they? And then if you have a negative and a negative, they push away. And if you have a positive and a negative, then they attract to each other. But you did all this in chemistry, yeah? Okay. I can go down? Yeah. Some materials allow electrons to flow. Yes, come on. So some materials allow electrons to flow with ease. What type of materials? Yeah, like give us an example. Yeah, like what? Yeah, think of something a bit cheaper maybe. Copper? If we think about wires, yeah. Well, we'll just go with copper for the moment because that's what mostly is used in wires. So if you have some copper, it's very easy for these electrons to move inside of it. And in fact, I think you use this expression in chemistry. Do you use this with Lorraine? Sea of electrons? You say no. You've heard this one before? With Lorraine or not?
I've heard this one.
All the electrons are free to move, that's all. And this is called conductor. You know this word conductor in chemistry, yeah? So if the electrons can move easily, then we say it's a conductor. And the opposite, if something is not a conductor, insulator, yeah. Got an example of a good insulator? Plastic. Yeah. Plastic. Okay, so just to draw something here. You have that? Yep. Okay, so here, if you have a metal, the reason that the reason the charge can move through it is because the electrons can move through it. But the only difference when it's a liquid is that these are ions. Do you know what ions are? What's an ion?
Adding positivity and negativity choice.
Yeah, give me give me an example. Do you know from chemistry?
Chlorine, ion.
What's special about it? What makes it different to?
More electrons.
Yeah. So an ion is really just an atom that's not balanced. Yeah. Maybe it has an extra electron, or maybe it has one less electron. So for example, if I want these to be negative, does it need more or less electrons? More. So maybe it has an extra, like an electron. So this is how the charge can move through the liquid then. So I just need to give you some vocabulary. This is called an electrolyte. Wait, the liquid is, yeah. And this is just your regular metal conductor. And this is a solid, and then this is a liquid. What do you about gas? Do you think a charge could move through a gas? What do you think?
Yes, very.
Huh?
Very little.
Maybe very little charge? What gas do you think of, who?
I'm not sure.
You just think it's possible, yes? Well, it is. You can't have a gas so you can have a gas and you can have a charge running through it. By the way, it's both electrons and ions that move through a gas that passes the current, that passes the charge. But I do wonder if anybody knows what gas. The gas that allows this. I think you do all know. You might have some explosion issues there. Same with oxygen. I think. Do you know a butcher's? Butcher. Do you know butcher? Where you go to buy your meat. The shop that sells only meat. You know this shop, butcher? Outside the shop there might be a sign. No? Outside the shop there might be a sign, and the sign might look like this. Let me draw it for you. It doesn't have to be a butcher's. I always think for butchers, but like it could be any shop. So outside the shop you could have this, let me draw it for you. Here's the building, and here's the window. And then there might be, on the window, this. Come in, and it's flashing. You know these signs? Yeah. This is an example of this. This gas here is neon gas. Neon, yeah. And when you pass a current through neon gas, it lights up. So neon allows this. So neon gas at low pressure. Okay. Can I go down now? So we can have a look at some definitions to start now. Okay. So, a current is a flow of electrons that is a movement of charge. A 1 amp current is 1 coulomb per second. So here's our first definition. 1 amp is 1 coulomb per second. Now, you can actually see amps on things at home. Like, let's see if I can plug here. Yeah. Try and show you. Show you what? If you look, I'll come over here. You see, at the bottom it has 13A there. You see that? 13A? 13A?
Yeah.
And, well, you've probably seen this anyways, but that means 13 amps. So that means this here, when it's plugged in, there's 13 amps, 13 coulombs each second passing through it, okay? So that's what amps mean. So we have our first formula using this definition. This is charge, and it equals to current multiplied time. Or sometimes people just write Q equals IT. So let's do a small example then. Can I scroll down? Okay, so here's our example. So I have on here is my light bulb. And let's say there's 2 amps of current here going through it, and let's say it's on for 10 minutes. So my question then is, how many electrons go through the light bulb? Okay, so first we have Q equals IT, Q equals 2, and the time should be in seconds, so that's 10 multiplied 60. Yeah? Okay, so that's 1200 coulombs. Okay? Now that's how many coulombs of charge go through the light bulb, but we would like to know how many electrons. So you should still have from the start of the lesson what the charge of one electron is. So one electron is 1.6 times 10 to the minus 19 coulombs. So then the total number of electrons would be this. Can you do that on your calculator, please? Okay. Okay? Yeah? Okay. Now, just some notes here about current. So when we draw it like this, it's like we're saying that going to the right is positive. So I'm going to just do a big plus here. So we always try and go into the positive. So if it's going to the right, we say the current's flowing to the right. Okay. This is unfortunate because, in fact, the electrons, they're actually going to the left in the picture. So you just need to remember that when current flows, from A to B, then that means electrons move from B to A. Okay. Now, there's actually a way to measure current. I'm sure someone knows. What's the name of the machine that can measure current? So, if you want to measure how much current is going in this wire, you use a machine called a ammeter, and it tells you how much current is moving through it. So this here, ammeter measures current. So what you do is you just connect it to each end, that's all, and then the current flows through it, and then it will tell you on the screen how much current is flowing through it. So it's simple to use. Okay. Right, we'll go on to the next one.